in science? Yeah, in science we have started our lesson number 1, which was our chemical reactions. Yeah.
Yes.
So in chemical reactions till now, actually just tell me up to where I have taught you. I have given you an introduction of the chapter.
Yes.
Then we have discussed our activity 1.1 of magnesium.
Yes.
And then we have second and third activity of lead nitrate and zinc granules.
Yes.
Okay, balancing the chemical equations have I taught you?
उसका simple वाला बताया था, tough वाला
Tough one
that
is okay. Have you given the test?
Yes, ma'am.
Okay, so I'm starting the chapter from I'm making a revision of the chapter, okay, from the starting, because it's just a page. So we have started our lesson number 1, that was, you have the textbook?
Yes.
Okay, so we are at the front page, yeah? So we have started our lesson number 1, that was the chemical reactions and equations. I introduced you to the chapter, whatever we are going to study in this chapter. Yeah. So the chemical reactions and equation, I started the chapter with the introducing you with the kind of change. We have two changes, the physical and chemical change. So chemical reactions shows us what the chemical changes in the form of the reactants and the products. Yeah. Now, the raw materials are known as the reactants and the new products formed are known as the products. Okay. Then I gave you an few of the example that what happens when the milk is left at the room temperature and iron tawa is exposed to humid atmosphere. Then food is cooked, we respire. Some of the common examples which I gave you, which were all under the categories of the chemical change. Yeah. Then we started with our activity 1.1, in which we read that when we have to take a magnesium ribbon, you don't need to take a very long amount, a large ribbon, just a few 2 to 3 centimeter ribbon is enough for the experiment. Yeah. So you have to take 3-4 centimeter long magnesium ribbon and you have to clean it with a sandpaper. Now, you know very well magnesium is a metal. Yeah. So what are the properties of the metal? Can you name some of the properties of the metals?
They are malleable.
Hmm.
And they are ductile, like
Yeah.
they are lustrous.
They are lustrous.
And make sound.
Make sound. Okay. You told me the word malleable. What does the word malleable defines? How you're going to define this word, the term?
It can be converted into thin sheets.
Yeah. And what about the ductility? Can be converted into thin
wires.
Wires. Good. Then you told me that the metals they produces sound. So what is the term which is used for this?
Sonorous.
Okay. And the lustrous means?
Shine.
Good. So in this activity 1.1, you have to firstly take a magnesium ribbon, which is a metal, obviously, and you have to clean it with a sandpaper. After cleaning it with a sandpaper, you have to hold it with a pair of tongs because obviously you're not going to hold it with your hands. Yeah. So you have to take a pair of tongs and you have to take the ribbon and you have to burn it with the use of the spirit lamp. So since it is a piece of ribbon, it will burn in the presence of oxygen. Yeah. And after the burning, we will notice that if you are going to burn a paper also, so paper forms the ashes, the black color ashes, right? Similarly, is the case of this magnesium ribbon. When you're burning this magnesium ribbon in the presence of oxygen, that is understood. Yeah. In the presence of oxygen, we see that the magnesium ribbon slowly gets converted into a powder that we normal language we call it ash. Yeah, since it is a metal, we are not calling it ash, we are calling it powder. And then you will notice that the magnesium ribbon, when we burned it, we get the white powder. Yeah. Also, now you have to take care of the color of the flame. When this magnesium ribbon is burning in presence of oxygen, then it gives a white dazzling flame. Like in the case of crackers, you might have seen the white dazzling flames comes, not in a very large flame, but a small flame will appear. Yeah. So now the question is asking you that what you will observe. So the first thing you are going to observe is that the ribbon you take gets converted into white powder. Second thing which you're going to observe is the white dazzling flame. Yeah. And since this is a chemical change, is it? Why is it a chemical change?
Because the magnesium ribbon is burning with oxygen. So if it is forming magnesium oxide,
Yeah, but how you will say that it is a chemical change. What are the properties of chemical change? That we cannot get the original product and the new products are formed. Yeah. So these white powder cannot be converted back to the magnesium ribbon. Yeah. So clearly you tell your answer. No need to worry. Then the second thing is that the new products are formed. And what is the new product form in this case?
magnesium oxide.
Magnesium oxide. Great. Now, if you have to explain it in the form of a reaction, because the chapter we are studying is chemical reactions and equations. Yeah. So the chapter which we are studying now, this is obviously a chemical change. So this chemical change can be expressed in the form of equation. How are you going to express it with the help of equation?
In words or like symbols?
In a form of symbols, you can tell me.
Okay. Mg plus O2 is equal to Mg.
MgO. One more thing, it is not is equal to, you have to use an arrow. Yeah, and you have to use only a forward arrow because it is not a reversible change. Yeah, so single arrow you are going to use that will be going from the left to the right. Yeah, it's good. Then second activity, we read that the lead nitrate solution was taken in a test tube, and another test tube we have taken a potassium iodide solution. So as you can see, both are the solution in laboratory. When your teacher will demonstrate you, they both are in the form of powder. So firstly, you have to make it a solution by adding a water. Then you will carry out the experiment. Okay. So in a solution, in a lead nitrate solution, you will add the potassium iodide solution. When you will mix the solution, now in this case, we are not using any external source, no heating, no light, nothing. Just mixing the solution. And this is also very important activity. Yeah. So when you are going to mix these two solutions, lead nitrate solution and potassium iodide solution, they're asking you what you will observe. So mixing these solutions, they will dissociate each of the solution into its respective ions. For example, you have taken lead nitrate, lead is a metal and nitrate is a non-metal, will dissociate as lead plus and nitrate minus. Understood how? Because lead is a metal, positive one, and the nitrate is a non-metal, that's the negative one. Similarly, when potassium iodide solution will break into ions, then the potassium will have the positive charge and the iodide will have the negative charge. So here I would like to ask you a small question. Why does the metals are having the positive charge and the non-metals, they have the negative charge? No? Okay. Let's just take it this way. In class 9, we have studied the Bohr's model. Have you? In the
Yes.
Bohr's gave us a concept of filling the electrons in the shell. Remembered? So he gave the formula to us that was the 2n square. Remembered? So in first shell, we can fill maximum 2 electrons or less. Second shell, we can have 8 or less. And third, we can have 18 or less. Yeah. So for if you take example of any metal, suppose you are taking an example of the sodium. Yeah. Sodium has the atomic number that is 11. So first shell will have how many? 2 electrons. Second will have 8 electrons. And the last one, we have remaining 1 electron that will come to the third shell. Yeah. And also we have to follow the rule that is known as the octet rule, that an atom will be stable when it will be equal to its nearest noble gas. Yeah. And the nearest noble gas to atomic number 11 is argon. That is 18. Yeah. Not argon, sorry. It is helium. It must be, I guess, neon. Hydrogen, helium, boron, carbon, nitrogen, oxygen, chlorine, neon. I guess it is argon 20, if I'm not wrong.
Yes.
So, argon. So you from the 11, you have to make it either 20 or either 10. 10 is neon and 20 is argon. So in our last orbit, we are having 1 electron. So what will be more easier for an electron, to gain 7 electron or to lose 1 electron?
One electron.
To lose 1 electron. And since the sodium metal is losing the electron, it have the positive charge, and it is losing 1 electron, its valency become positive 1. So metals, they have positive charge because they lose the electrons. Similarly, in the case of non-metal, if you take an example of the chlorine, that's 17. Yeah. So can you tell me the electron distribution in first shell we will have?
2,
The
8,
next?
8,
And then?
and then 7.
7. Now in this case also you have to complete the octet. Now gaining 1 electron would be easier or losing 7 electrons?
Gaining 1 electron.
So that's why non-metals, they gain the electron. That's why they have the negative charge, and the metals, they lose the electron, they have the positive charge. Yeah. So there is no tukka that the lead will be positive only and the nitrate will be negative only. It has a specific logic that metals have the positive charge because they lose the electrons, and the non-metals have negative charge because they gain the electron. Yeah. So the lead will have the positive charge, nitrate will have the negative charge, and the potassium will have the positive charge, and nitrate will have the which charge? Iodide?
Negative.
Negative. Now when we'll mix these solutions, so all the ions will be interchanged. Like the lead's positive will form the formula with the potassium's negative. Yeah, iodide one. And thus we will get again two products that will be your lead. Can you tell me what are the two products? Just exchange their ions. Since lead is having the positive, to take the negative of the iodide. So it will be lead what? Not getting? Okay, let's take in this way. These equations, they require thorough practice. See, what I'm trying to explain you is that, just a second. Yeah. What I'm going to explain you is that here you have taken lead nitrate. Yeah. Solution, and you have mixed another solution, that is your potassium iodide. Understood up to here?
Yes.
Okay. Now what is the formula for the lead nitrate? Lead is
Gauri, if you have any doubt, you can ask in between also, okay?
Okay, sir.
now the symbol of lead, Samika, what is it?
PB.
Pb, and nitrate is
N.
O3.
NO3.
Yeah. And since the lead has the valency 2 and nitrate has valency 1, the formula will be PbNO3 whole twice. Understood up to here?
Yes.
Then that's potassium iodide. Potassium is K, iodide is I. Yeah. Both have the positive valency, that's +1, and this is -1, so formula remains the same. Okay. Now I'm asking you, when we are going to mix these two solutions, what will be the product? So lead have the positive charge, nitrate has a negative charge. Yeah. Potassium has a positive charge and iodide has a negative charge. So obviously the positive will not be forming formula with this nitrate, but with the negative of the other. Yeah. And this positive will be forming the formula with this negative. Understood now? So this lead will form the formula with this iodide. Understood now what I was trying to say? So
Yes.
it will be PbI, but the valency of lead is +2 and iodide is -1, so it will become PbI2. Understood? And this positive will form the bond with this negative, so it will be your KNO3. Checking the formula, the potassium has the positive one valency. Yeah, nitrate has a negative one, so formula remains the same. So when we are mixing the two solutions, we are getting the two products by dissociating them into their ions, or in a simple language, you can say by exchanging their ions. Understood now formula? You need, this is a very important activity. Every year it comes in the board examination. Okay.
Yes.
The next up we have activity 1.3. In activity 1.3, you have been told you have to take few zinc granules and you have to add dilute hydrochloric acid. What is the formula for the hydrochloric acid?
HCl.
HCl. So what will be our desired product? Now see, in this case we have zinc, that will be obviously positive because it's a metal. Yeah. Then we have HCl, hydrogen will be always positive. There is no hydrogen that exists in the nature. And then we have the chlorine negative. Yeah. Now can you tell me this positive is going to form the formula with this negative, as I told you? Yes. So what will be the product?
ZCl.
Where the N will go, it is complete Zn.
Just a minute. ZNCl.
ZnCl and
Hydrogen H.
hydrogen. Now see, we have written in a rough way. Now we are making the formula. Now the zinc has the valency +2. Yeah. And what is the valency of chlorine? That is -1. -1. So what will be the formula exchanging their ion? It would be ZnCl What will come here?
2.
Yeah. And H we don't like in this way. We write the H in of H2. It's a molecule and also it's a gas here. Understood? So this is your product, that is hydrogen gas and zinc chloride. And also it is the second part of the equation where they are asking you when you have to perform same activity with sulfuric acid. Yeah. Sulfuric acid, the formula for sulfuric acid is?
SO.
Yeah, H2.
H2SO4, yes.
Yes, that is your H2SO4. Understood? Now the zinc is a metal, will have which charge?
+2.
+2. And hydrogen being a positive charge and sulfate is the negative one. Understood? So
Yes,
the positive is going to form the formula with the negative one. Yeah. And since we have nothing negative here, yeah, so it will just form H2. Now we have ZnSO4. Yeah. So the valency of sulfate is -2. Now this is +2 and this is -2. The formula remains the same. Yeah. And then again we have the another gas which is hydrogen gas. Now this question came in the board examination as you have to give an example where a metal reacts with an acid. And the second part of the question was asked in the board examination this year was which gas is being liberated. Understood now how these types of questions come? Okay.
Yeah.
Yes. This was up to here. I have already taught you. Chemical equations we have discussed. That a chemical equation, can you just give me a small note on chemical equations which we have studied till yet, because already you have given a test of this, yeah? Have you?
Yes, ma'am.
Yes. So can you tell me about 2-3 lines over this chemical equation? What is it and what is all about?
Like a representation of chemical formulas with the use of symbol.
No,
and
if the question comes, what is a chemical equation? So how you will define it?
It is an equation which represents the chemical reaction using symbols and formulas.
Yeah, then a chemical reaction is composed of reactants. They react together. Yeah. Be more specific that in a chemical reaction, the reactants react with each other and they form the desired product. Yeah. And there are two ways to represent a chemical equation. The first one is a word equation and second one is your symbolic form. The test which I gave you was in symbolic form. Yeah. Okay. So then the balancing I have already told you. In easier way, first level I've already told you, discussing with you about the second level. Okay. Yeah. So in second level, there is nothing more. Yeah, it's the same. There is just an additional step. Like for example, let's say take the same reaction which we studied in our activity 1.2, where we took the lead nitrate, that is your PbNO3. You also keep writing because answer you are going to tell. Okay, so write along with me. In our activity 1.2, we have took the lead nitrate and we have mixed the potassium iodide to it. That was your Ki. Yeah. And then we form the product that was your PbI2 and KNO3. This was the equation. Can you write the equation by yourself?
Yes, ma'am. Yes.
Just try to write down. If you are stuck, then you can see over the camera. In your school, what is going on from this chapter? Where are you at?
Ma'am, we have not started chemistry yet.
Oh, you have not started. Okay. What's going on in school? Physics or bio?
Both physics and bio.
Okay. Have you written?
Yes, ma'am.
Now, as you can see in balancing, what we used to do was just a balance the number of reactants and the number of product. But now here, as you can see, the PbNO3 has a bracket in it. Yeah. Now we have to open this bracket. That's an additional step. So that will be your PbNO. I have done nothing, just open the bracket. Yeah. Now the nitrogen, you can see here is one nitrogen and two on the outer side. So 1 2 is 2. Understood? So nitrogen becomes 2 here. Oxygen is 3 and this is 2. So 3 2 is
6.
Yeah. So it now becomes PbNO2O6 plus Ki gives you PbI2 plus KNO3. Yeah. Now you balance this equation and let me know the answer. That's it. In case any bracket has been given to you, you just open up the bracket, but the answer which you are going to write must be in the main equation, not the open bracket equation.
Ma'am,
Yeah, Gauri?
in fourth question, should we find the HCF and LCM?
Look, let me see. In your question number 4, it has been told you that there is a rational number that is 327.7081.
Yeah.
What can you say about the prime factors of Q when it is expressed as P upon Q? So firstly, you have to express in the form of P upon Q by reducing the decimal. Then you have to take out the prime factors and check. Can it be expressed in the form of prime factors or not? Okay. Yes, Samika, have you done?
No, ma'am.
Okay. Gauri beta, you have just 10 minutes left for the test. Yeah, just speed up. You're in, I think, question number 4.
No, I'm in 6.
You're in 6. Okay. You have 10 minutes left. You have to do the test and revise it also. Okay.
Ma'am, can you tell me this one?
Can I tell you, have you balanced the equation?
No, ma'am.
No, what happened while where you're stuck? See, the lead on the left hand side is 1 and the lead on the right hand side is 1. It's balanced. Moving forward to your nitrogen, on the left hand side it's 2, but on the right hand side it is how much?
1.
Okay, so try to put 2 on the right hand side. Take one element at a time. Okay. So nitrogen, I have also put 2 on the right hand side. Now nitrogen is balanced, 2 on the both the side. Yeah.
Yes, ma'am.
Now moving forward to our oxygen is 6 on the left hand side and 3 we have on the right hand side. Not 3. Again, we have 3 to the 6. Understood? Oxygen is balanced. Check.
Yes, ma'am. Because in
Yeah.
nitrate,
So oxygen is balanced, nitrogen is balanced, and our lead is balanced. Now moving forward to our potassium, the potassium we have 2 on the right hand side, but on the left hand side we have 1. Can you see? So what we are going to do? Put 2 on the,
left hand side.
yeah. So when you have put on 2 on the left hand side, so ultimately your iodine is balanced. That is 2. Yeah.
Yes.
So your entire equation is balanced. Giving you some more kind of such questions. I'm writing down, kindly note it. We have K2Cr2O7 plus, oh, sorry, wait. Let me give you an easier one. Just wait a sec. So we have NH4 to SO4. Have you written this equation?
Yes,
Yeah,
ma'am.
balance it. Till then I'm writing more. See, I've given you 2 more reactions. Just write these one.
Just a minute.
Gauri, have you completed your test?
No, the last question.
Okay.
Yes, ma'am. Written.
Have you written the examples, Samika?
Yes, ma'am.
Have you balanced the equation?
Ma'am, I've balanced the first one.
The first one, have you done, Samika?
Yes, ma'am.
Ma'am, the third question is in, we have to write in statement or,
Which one, the third question?
yeah,
Let me just go through it. See, the third question is asking you that can the two numbers have the 18 as their HCF and 380 as the LCM?
yeah,
If you're writing yes, you have to give the explanation. And if you're writing no, then also you have to give an explanation because they have asked you to give reasons.
mm.
Samika, have you done the second one?
Yes, ma'am.
Doing the last one?
Yes, ma'am.
Okay.
Ma'am, I completed the test.
You have completed the test?
Yeah,
Just check properly the test. Yeah, take care of the numbers, haven't you? Because this time, if you have misread the question, I'm going to deduct marks. Last time you did that. Yeah. So
yeah.
carefully go through the questions. When it's done, you submit the test to sir. Okay. Okay.
Ma'am, done.
Can you share the answers with me of the first reaction?
Ma'am,
Hmm.
it is NH8 SO4.
No, just tell me the balance numbers.
Okay. Na2SO4 plus 2NH4 HCl.
Just 2 NH4Cl. That's it.
Yes, ma'am.
Okay,
Like,
let me check. Let me just go through it. On left hand side, we have nitrogen 2. The right hand side, we have 2. Good. Left hand side, we have hydrogen as 8. And right hand side, we have 4 to the 8. Okay. Then we have sulfur 1, oxygen 4, 4. Na, no, the sodium is not balanced. Check. The sodium is 2 on the right hand side and 1 on the left hand side.
so ma'am, like
Yeah.
just a minute. I had added 2 NaCl in the like left hand side.
You have written 2 NaCl.
Yes, ma'am, in LHS.
I have not heard, okay. So just you have put 2 NaCl and 2 NH4Cl, yeah?
Yes, ma'am.
Then the equation is balanced. Okay. Moving forward to our question number 2, that was PbOH whole twice plus HCl. What have you done here?
PbO2H2
No, the numbers, just the numbers of the balanced one.
Like PbCl2 plus H2O2.
Yeah. What you have written on the right hand side?
PbCl2 plus H2O2.
It's the same.
Yes, ma'am.
And on the left hand side, is there anything to write down for balancing?
I added 2 before HCl.
2 before HCl. Let's check. On the right hand side, left hand side, we have lead 1. We have O2. No, oxygen is not balanced. Check. On the left hand side, you have 2 oxygen. On the right hand side, that's 1 oxygen.
So, ma'am, is it possible to add 2 in right hand side like H2O2?
Yeah, that's on what you have to do. So that will be your 2H2O here in this case. Yeah.
Yes.
Now the oxygen is 2 on both hand side. Also, as you can see, hydrogen on the right hand side is 4. And on the left hand side, we have hydrogen 2 of HCl and 2 of lead. So 4 is balanced. Yes. There is just addition and multiplication, nothing else. No minus, nothing. Then moving forward to
Hydrogen is balanced. Like in right hand side, we have 2 H2O, and in left hand side, we have 2.
see, on the right hand side, we have 2H2O. So hydrogen is 4 on the right hand side. Yeah. On the left hand side, there is 2 hydrogen from the lead hydroxide. Yeah. And 2 hydrogen from the HCl. So 2 plus 2 is 4.
Okay, ma'am.
And then HCl, there will be 2, and 2 is already on the right hand side. So that's the answer will be 2 HCl plus 2 H2O.
Okay, ma'am.
Okay. Coming towards your third one, do you want to see again the question number 3? Because 2 I have already explained you. Do you want to
Ma'am,
repeat?
the match answers, like I'm not
Huh?
sure.
You're not sure?
Yes, ma'am.
You have to be sure. Just recheck it again, and then you tell the answers. Yes, Gauri?
Yes, ma'am, I'll send the picture.
You have sent the test?
No, I'll send it now.
You have sent it?
I'll send it now. I was checking.
Okay. So that's it. Tomorrow we'll begin with our science.
Okay, ma'am.
Okay.
Yeah. Thank you.
Oh, welcome. Is there any question you felt the problem?
Yeah, third and fourth.
Okay, we'll discuss it tomorrow. Yeah?
Yeah, okay, ma'am.
Okay. Thank you. Was the test hard, Gauri?
Easy. Fine.
Easy, no? The chapter is quite easy. The starting 2 chapters. Now in your school, lesson number 3 started, the linear equations.
Yeah.
Okay. We'll start then.
Thank you.
Welcome. Yes, Samika. Question number 3. What you have done here?
So 2 AgNO3
Okay.
plus Cu
Plus Cu.
gives CuN2O6
Okay.
plus 2 Ag.
Okay. The balancing you have to do in the main equation, right? The breaking thing you are doing, that's for yourself. Yeah. So balancing must be here in this 2 AgNO3 and 2 CuNO3 whole twice in main equation. Okay. This additional step is for you. Okay. So let's just check. We have 2 silver on left and right. That's good. We have copper on the right hand side. That's balanced. We have nitrogen. We have 2 nitrogen on each side, and we have 6 oxygen. Yeah, it's balanced. Good.
So ma'am, what will be the last equation formed in this answer?
The last equation is the same which you have told me. That will be 2 AgNO3 and 2 Ag. I'm just telling you the numbers which you are putting should be in the main equation which the question is giving you, not that open bracket equation. Okay. Okay, now moving forward, the chemical equation is done. Now we are in your page number 6. In page number 6, 3 in-text question has been given to you. The 2 and 3 would be your homework. You have to form the symbolic form and balance it. Have you got the questions? See, the question number 2 is you have to give the balance equation for hydrogen, chlorine, and hydrogen chloride. So what will be the symbols you have to use?
Hydrogen, chlorine, HCl,
H2,
H hydrogen chloride, H2Cl.
No, wait. On the left hand side, it's hydrogen plus chlorine. So hydrogen will be H2 and
H2 plus Cl.
gives.
HCl.
Question number 2 will be barium chloride. That will be BaCl2, right?
Yes, ma'am.
Plus aluminium sulfate. What will be the formula? Try to make the formula.
Barium is BaCl.
2. The barium has valency 2. And the chlorine has valency 1. So it will be BaCl2.
BaCl2 plus Al.
The formula you will not be able to tell orally. Just try to make the formula in copy and then you tell me. You can just write down the entire equation and show me. The balancing would be your homework. Question number 2 and 3, make the equation and show me.
Ma'am, no. Can I come in a second? Actually, someone is at the door.
Sorry, what you are saying?
Can I come in a second? Actually, someone is at the door.
That's all.
Yes, ma'am.
So have you formed the equations?
Yes, ma'am.
All the three parts?
No, ma'am.
No, ma'am. Okay, have you done the first part only?
Yes, ma'am. Actually, I was facing issue.
Oh, no problem. Okay, you tell me the first, the remaining we can have for the homework. Okay?
Yes,
Okay.
ma'am.
Tell me.
2 BaCl2
Hmm.
plus 2 AlSO4.
No, the formula is wrong. AlSO4. What is the valency of aluminium? That is 3.
Three.
And the sulfate is 2. So when you will exchange, you will get Al4 whole twice. SO4 twice. Just check. The formula, the valency of aluminium will be 3. Yeah. And the valency of SO4 will be 2. So when you will exchange their ions, write down Al first. Write down Al on the left hand side, SO4 on the right hand side. Then write 3 above Al and 2 above SO4. Now you exchange their valencies and frame the formula. Yeah. What now?
Just a minute.
Do you need my help? Or can be done by you?
I need help.
You need help. Okay. See, what I'm going to tell you is that you have barium chloride. So this is your barium. Try it this way. Okay. Firstly, write down the roughly symbol. Barium is Ba, Cl is Cl. Yeah.
Yes, ma'am.
Now the barium has valency +2, chlorine has -1. Yeah. So it will be BaCl2. Done.
Yes,
Then
ma'am.
similarly frame for AlSO4. Aluminium is Al, SO4 is SO4. This is +3, this is -2. Frame for it.
One. Ma'am, Al2SO4.
Now see, exchanging this 2 will come here, Al2.
SO4.
This 3 will come here, but in the form of bracket. Now you understood how you are framing the formula?
Yes, ma'am.
Okay, now on the right hand side, you have barium sulfate. Barium is Ba, sulfate is SO4. Yeah, both have the valency. This has +2, this is -2. No need to put 2. Yeah, and after barium sulfate, you have aluminium chloride. So aluminium is Al, symbol, chloride is Cl. Yeah, the valency of aluminium is +3, Cl is -1. So frame the formula for AlCl. It will be
Al1Cl3.
no need to write 1. It will be AlCl3.
AlCl3.
Yeah, in this way you frame the equation. You cannot make the formula at once. Firstly, as I did, write down the or if you are comfortable, just write on the right hand side the formula and then you put on the left hand side on the fact page. Yeah. Okay. Now this was your second question. So your homework of today's will be your question number 2 and question number 3, all the parts. Okay. Question number 1, you will tell me right now. That is the why a magnesium ribbon should be rubbed with the sandpaper while burning in the air, before burning in the air. What happens?
To clear the particles of that magnesium ribbon, as it is basic in nature.
No, just give me one answer and the proper answer. You know very well it is clean with sandpaper. Why is it so?
To clear the layered particle
no particles. You know very well when the aluminium reacts with oxygen, it forms magnesium oxide. Is it? So we are rubbing it with sandpaper to avoid or to prevent the layer of magnesium oxide that is again formed. Yeah, because before burning, when it is coming in contact with oxygen, it is forming magnesium oxide. Yeah, because the metals, when they combine with the oxygen, they form metallic oxide. Similarly, non-metals, when combined with oxygen, non-metallic oxide. So when the magnesium combined with oxygen forms magnesium oxide. Similarly, you can take example of another metals also, like aluminium. If you are taking, it will be aluminium oxide. Sodium, if you are taking, it will be sodium oxide. But we cannot clean all the metals with the sandpaper. Yeah, so in this case, we have been asked, we have to clean the magnesium with the sandpaper. Now you tell me the answer, the proper answer. Yeah, why a magnesium ribbon should be cleaned with the sandpaper? To prevent the layer of?
Magnesium oxide.
Yeah. And how it is formed when when that metal is coming in contact with?
Oxygen.
Yes. So when that metal is coming in contact with oxygen, it is forming magnesium oxide. And when we are burning it, then that magnesium oxide is being converted to white powder. Understood? While burning, it is not forming oxide. Oxide, it is formed already. When we write the equation, it's Mg plus O2 gives MgO. Yeah. So when it is happening, before burning, it is happening. After burning, it is forming that white powder. Okay. Now the first kind of reaction, now the next heading is the types of chemical reactions. As you can see in your book, our next topic. The first kind of reaction you have been given is the combination reaction. So how you will define this combination reaction? The combination means when two things combine with each other, get mixed with each other. Yeah. But we cannot categorize all the equation as combination reaction. So what is the proper definition of the combination reaction? A combination reaction is the one where two or more reactants combine to give a single product. Understood? Two or more reactants, they combine to give a single product. Simple one line definition: when two or more reactants, because obviously reactant cannot be one when it is mixed. So when two or more reactants, they combine with each other and they form a single product. Now in your activity 1.4, as you can see, you have taken a small amount of calcium oxide. Yeah, CaO. And then you have added water to it slowly, that is H2O. Yeah, so it is CaO plus H2O, right? The product that is being formed is calcium hydroxide, that is CaOH whole twice. The question is asked, the activity is asking you, you have to feel the change in the temperature. Now when you are mixing water in the calcium oxide, and after mixing, when you will touch the beaker, you will feel some amount of hotness in the beaker. It will get hot, not the considerably high hot, but a normal hot. So when we have read the two kinds of reaction, that is exothermic and endothermic, in which the absorption of heat takes place, and in the other one, release of the heat takes place. Yeah. So now in this case, what is happening? The heat is being given out. That's why the beaker has become hot. So the reaction, as you can see in your book, it is given CaO plus H2O. They are the reactants. They combine together and they are giving a single product, that is CaOH whole twice, calcium hydroxide. Yes. Plus heat. Now for the heat, we don't have any formula, and in heat and the heat we don't consider in the product. Like if you will say, ma'am, it is the two products, heat and the calcium hydroxide. So the product will be one only. Heat is the medium that is being released. Yeah. Similarly, other example, as you can see, a yellow box is given, that is very important, that a solution of slaked lime produced by the reaction is used for whitewashing wall. You know whitewashing?
Yes, ma'am.
Yeah. So in this case, as you can see, the calcium hydroxide which we have formed, how we form? We just now form the calcium hydroxide by mixing water with calcium oxide. Yeah. So when the calcium hydroxide is mixed with carbon dioxide, how it is being mixed? We can keep the solution of the calcium hydroxide for 2 to 3 days so that the carbon dioxide gets mixed with it. Yeah. So when the CaOH whole twice gets mixed with the CO2, we are getting calcium carbonate and H2O. Now in this case, as you can see, we are getting two products, calcium carbonate and water, H2O. It is not a combination reaction because we are getting proper two products. Yeah, this reaction is very important, both of the reaction, calcium oxide and also the calcium hydroxide one. So you have a reading of this page number 7. They all are the examples of the combination reaction. We'll discuss it tomorrow. And do your homework honestly. Yeah. Okay. That's it for today. Thank you.
Yeah, bye, ma'am. Thank you, ma'am.
Oh.